Okay, here's a graph of y is equal to sine of x. And for its derivative, okay, for its derivative graph, we know it's going to be y is equal to cosine of x. Okay, if we assume for a second that we don't actually know that the derivative of sine of x is cosine of x, we can still use this fact. Do you see how here we have a slope of 0, slope of 0, slope of 0, and slope of 0? So the derivative at those x values will have a 0. Okay, notice that it's right in the middle, right when we have a maximum minimum value. And note that here the slope is positive and that slope is 1. So we're going to start at 1 and we're going to come down to, notice that it becomes less and less positive. So we have to come down lower and lower in the scale of from 1 all the way down to 0. Okay, and here the slope is -1. So right there it's going to go down to -1 and go back to 0. Okay, maximum of 1, 0, right? Like that. Okay, so that's the derivative curve, and of course that is the cosine of x curve. Okay, note that this looks like, right? It's the sine curve just shifted to the left by, okay, this is pi, so by pi over 2. Okay, so if we call this f at x, the derivative, okay, the derivative will be simply f at shift the graph, the original sine curve, to the left. So that's x plus pi over 2. Okay, so the derivative graph is the original graph shifted to the left of pi over 2. In other words, it's sine of x plus pi over 2. Of course, this is going to equal to cosine of x. Okay, the third derivative. Okay, look at the blue graph, which is the first derivative graph. Wherever that has a horizontal, okay, tangent, the second derivative have a value of 0 there. So look, 0. Do you see that these all have a negative slope value? Okay, that's also 0. So it's gonna do this. And guess what? Again, here is 0. So it is going to be 0, but it's going to be exactly, compared with the original y equals sine of x, it's exactly a reflection. Okay, it's a reflection on the x-axis of the original function. Of course, if you differentiate this one more time, okay, we get minus of sine of x, which exactly, you know, what we said it was going to be, right? Just a reflection of the original function. So it's minus sine of x. Okay, so using this, we can predict the third derivative. Right, the third derivative is going to be minus cosine of x. The fourth derivative is actually going to be turned back into positive sine of x. And the fifth derivative is going to be cosine of x again.